Hi, we are Aquario, and our project is the Yuma Crossing Interactive Exhibit. Our team sponsor is the Yuma Crossing National Heritage Area. Our team members are Victor Ramers, Melanie Marine, Rafael Ortiz, Eduardo Alvarez, Alan Vega, and Christian Pascasio.
Scope: to design and build an interactive topographic model of the lower basin of the Colorado River. The introduction of an exhibit with different technical characteristics will help attract and inform visitors about future challenges communities will face with water allocation of the Colorado River. Design description. The final design concept utilizes the 32-inch Android touchscreen tablet that will simultaneously display the main menu and video with informational text provided by Yuma Crossing National Heritage Area. The system users can use their finger to navigate through which dams they would like to get more information on. The main menu will always be displayed on the side to have options available at all times. A Raspberry Pi 4 model provides the logic process necessary to control the LED functions to illuminate the river with blue LEDs, the cities and landmarks with red LEDs, and the dams selected by the user with green LEDs. The topographic model base was designed to be easily disassembled for transportation or required maintenance. The topographic model is designed to be removed from the base, exposing internal electrical components such as LEDs, processor, and wiring. This system design satisfies all of the expectations as expressed by the client while having a decor which is both aesthetically consistent with the surrounding vintage environment and providing a modern and technological contrast to the atmosphere. Concept of operation, system environment. The recommended operating system temperature ranges from 32 degrees Fahrenheit and 100 degrees Fahrenheit. It is ideal to keep the humidity between 30 and 40% to prevent failure of circuits, microchips, and other components. System boundaries. The system boundaries are established to define what is internal and external to the system. System users and employees are those who interact with the system directly. Employees set up, maintain, and transport the system from one place to another. External environmental elements such as temperature or power are another source of elements that can impact the system from an outside view. Expected output. Once the system user selects a function, the expected output is for the system to display LED light effects on the topographic model and to display information on the screen about the history of the Colorado River along with audio being produced for narration and engagement purposes. The LED colors consist of blue for the river, green for the dams, and red for the cities. System users will have the option to choose a different input to be displayed on the system. Public service. The Yuma Crossing National Heritage Area hopes the exhibit will help raise awareness about the future challenge communities will face with water allocation. Introducing a new exhibit with different technical characteristics will help inform new visitors about this particularly important subject that could affect many people. Components description. The model has three major components: a 32-inch Android tablet display, a Raspberry Pi 4, and a topographic model of the Colorado River. Display. The 32-inch Android tablet display is used to allow the visitor to interact directly with the system. When the touchscreen is touched by a finger or stylus, it registers the event and sends it to a controller for processing. A touchscreen may contain pictures or words that the user can touch to interact with the device. Raspberry Pi 4. The Raspberry Pi is the microprocessor that controls the system. The selected programming language is Python due to its ease of use. Base. The base was constructed using wood. The base holds the 32-inch touchscreen display and stores the Raspberry Pi. The base will hold the majority of the components and subcomponents, along with the main topographic map of the lower basin of the Colorado River. Software. The code was written using Python programming language which is what the Raspberry Pi requires. The GPIO pins in the Raspberry Pi serve as inputs and outputs. A total of 22 out of the 26 GPIO pins were used. 12 pins were used as LED outputs and 10 pins were used as inputs. The code was designed where the touchscreen had a total of 10 touch buttons that would send a signal to the Raspberry Pi and turned on an LED assigned that touch button. The LED would turn on for 60 seconds, then turn off. The LED could also be interrupted, which would make the LED turn off if another command was selected. Testing. The testing procedures identify the components to be tested, the test equipment, test conditions, parameters to be measured, and the pass or fail criteria against which the test result will be measured. However, due to a world pandemic and lack of resources, this phase of the project was never materialized. Instead, with the intent to provide some understanding of the procedure, we have selected two of the most relevant system requirements that can provide insight to what the test should be and the standard to which it must meet. The first set of requirements are the system interface requirements. The test would implement the use of a 32-inch AIO Android tablet display and a Raspberry Pi processor as user interface to accept and process input signals. The pass or fail standard for these requirements would constitute the ability of the input signal provided by the user to generate the expected output of the system. The next requirement selected to be tested is the internal interface requirement. This test would implement the use of light-emitting diodes, LEDs, of assorted colors to demonstrate different system states. The pass or fail standard for this requirement would be based on the physical and visual verification of the LEDs turning on or off depending on the user input signal. Budget. The Yuma Crossing National Heritage Area has an allocated overall budget for the project of $6,000, which includes both labor and materials. Our cost breakdown shows a total expense of $5,830.86 to complete the project. This is well within budget and has left an available balance of $169.14, which will be used for any unanticipated costs. Next steps. Due to the unforeseen circumstances of a world pandemic, the building and testing phases were never materialized. Nevertheless, a solid plan has been developed to see this project to its maturity. The team has been able to attain the majority of the project deliverables of the developmental phases and requirements. A project schedule was developed to help manage time, cost, quality, changes, risk, and related issues. With most of the deliverables already completed, a new team will be able to build and test the model. Aqua Rio has full confidence that its work can be the foundation for successful delivery of a high-quality product to the Yuma Crossing National Heritage Area. That concludes our presentation. Aqua Rio is very happy and proud to have had the opportunity to participate in this project. We want to thank our sponsor, the Yuma Crossing National Heritage Area, our mentor and professor, Dr. Samuel Peffers, and all the caring people who helped get this project running. We wish great success to the next team who will be able to pick up where we left off and see this project to its end. We can't wait to see the final result. Thank you.